How did 100,000 soldiers go to the toilet? Imagine an entire city. Now imagine that city moving across a continent. No modern plumbing, no sewer network, no modern sanitation system. In the late 17th century, when the Ottoman Grand Army marched toward Vienna, it became a moving metropolis of soldiers, servants, artisans, animals, wagons, and tents. Thousands of canvas shelters stretched across the landscape. Columns of horses, camels, oxen, and supply carts disappeared toward the horizon. From a distance, the army looked unstoppable. But beneath this display of imperial strength lay a quiet and relentless vulnerability. A biological clock that never stopped. Every day, every human being and every animal produced waste. If a commander failed to manage this basic reality, the army might never reach the battlefield in fighting condition. It could begin destroying itself. Throughout pre-modern warfare, dysentery, enteric infections, typhus, and other camp diseases repeatedly crippled armies before battle even began. Within days, a badly positioned and poorly managed camp could begin contaminating its own water and food. So how did the Ottomans prevent their largest campaigns from becoming biological disasters? Where did 100,000 men actually go? The answer is not found in battlefield tactics. It lies in the overlooked engineering of the military camp, in the positioning of water, in the movement of soil, in the work of anonymous laborers, and in a sanitation system that had to function every single day. Chapter 1. The Mathematics of Waste. To understand the scale of the problem, we first have to look at the numbers. A healthy adult can produce roughly 150 grams of solid waste every day. An army of 100,000 people could therefore generate approximately 15 metric tons of solid human waste in just 24 hours. And that was only the solid material. The same population could also produce well over 100,000 liters of urine every day. But an Ottoman campaign column did not consist only of fighting soldiers. It was an entire mobile society. There were bakers, blacksmiths, tailors, shoemakers, cooks, scribes, transport workers, animal handlers, servants, and administrators. The campaign artisans were known as the Orduku Esnafa. They repaired equipment, prepared food, maintained clothing, worked metal, and supported the daily life of the army. Once these non-combatants were included, the population of the moving camp extended far beyond its official fighting strength. And then there were the animals, tens of thousands of pack horses, mules, camels, oxen, and water buffalo moved with the army. These animals carried grain, tents, weapons, ammunition, cooking equipment, and personal supplies. But they also created an even larger sanitation problem. A single horse can produce many kilograms of manure and urine every day. Multiply that by thousands of animals, and the scale changes completely. Feeding the moving city was an enormous challenge. Keeping it clean was a matter of survival. Food could be rationed, supplies could be delayed, marching speed could be reduced, but waste production never stopped. Every sunrise, the calculation began again. Another 15 tons of solid human waste, another enormous volume of liquid waste, and another day of manure from thousands of transport animals. The sanitation problem did not accumulate once. It reset every 24 hours. Chapter 2. The Invisible Enemy. In the 17th century, no one understood bacteria, viruses, or microscopic parasites in the modern scientific sense. Medical writers often explain disease through bad air, known as miasma, or through imbalances in the bodily humors. But military planners did not need germ theory to recognize a brutal pattern. Filth and crowding were followed by sickness. Consider a single soldier relieving himself too close to a stream. Rain falls onto the disturbed ground. Contaminated water moves downhill. Waste seeps into the soil or enters the flowing water. Farther downstream, another soldier kneels beside the same stream and fills his leather canteen. The water may look completely clear. The danger cannot be seen. But within days, a trained soldier may develop severe diarrhea, fever, abdominal pain, and dangerous dehydration. A man who could previously march for hours and carry a heavy matchlock musket may no longer be able to stand. In a crowded military camp, the consequences spread far beyond one patient. Soldiers lived, ate, slept, and worked close together. Water containers were shared. Food was prepared in large quantities. Flies moved between damp ground, animal areas, waste sites, and field kitchens. Contaminated hands, utensils, food, and water could carry disease through entire units. Other camp diseases spread differently. Epidemic typhus, for example, was associated with body lice, crowded clothing, and poor hygiene rather than contaminated drinking water. But the military result was similar. A growing number of soldiers became unable to fight. Commanders could see enemy walls. They could see cavalry formations and artillery positions, but they could not see contamination moving through water, food, clothing, insects, and crowded tents. A soldier killed in battle was a casualty. 1,000 soldiers incapacitated by disease were a logistical disaster. They still required water. They still required food. They required transport, attendance, shelter, and medical care. At the same time, they could no longer march, stand guard, pull artillery, or fight. The invisible enemy did not simply reduce the size of an army. It could paralyze the entire command structure. Chapter 3. The Geometry of the Camp. A large Ottoman field camp was not simply a random collection of tents. It was an ordered, hierarchical settlement adapted to the terrain. The position of tents reflected rank, military function, administration, and access to supplies. Near the center stood the command pavilion of the Sultan, the Grand Vizier, or the senior commander of the campaign. Around this administrative center were the janissaries, cavalry formations, artillery personnel, officials, workshops, kitchens, supply carts, and animal areas. But the planning of the camp had to begin before the main army arrived. Advance teams inspected the landscape. They searched for clean water. They examined nearby pasture for the animals. They considered the surrounding high ground, the roads, and the tactical security of the site. They also had to identify where waste could be placed without immediately threatening the future living areas. Before the main rows of tents were erected, laborers could mark and prepare the sanitation zone. The most practical solution was the latrine trench. These were long, narrow pits dug at the outer edge of the camp. Whenever the terrain allowed, they were placed away from kitchens, food stores, sleeping areas, and clean water collection points. Lower ground could help separate waste from the central camp, but the position also had to avoid areas likely to flood. Wind direction, slope, soil conditions, and access routes all mattered. No surviving plan shows us the exact location of every latrine in the Ottoman camp before Vienna, and we should not imagine one universal design used in every campaign. But the logic of a temporary city imposed several unavoidable rules. Drinking water had to be protected from washing, animals, and waste. Contaminating activities had to be kept away from the cleanest part of the water source. Sanitation areas had to be separated from food and living quarters, and soldiers had to know where they were expected to go. Laborers dug the trenches using wooden shovels, mattocks, and baskets. The excavated soil was kept beside the trench. It could then be used to cover deposited waste periodically and to close the trench when it became full. Covering the surface with soil reduced direct exposure. It also limited access for flies and reduced the chance that contaminated material would be carried back toward the kitchens. Simple wooden posts and canvas screens could provide some privacy and define the designated area. At night, paths could be marked or supervised so that soldiers did not wander through cooking, sleeping, or water collection zones. When one trench reached its practical limit, it was filled with the excavated soil and compacted. A new trench was opened nearby. The system was simple. It required no modern machinery, but it depended on planning, distance, soil, labor, and discipline. Most importantly, it had to be prepared before the arriving army transformed the open field into a crowded city of canvas. Chapter 4. The Siege Bottleneck. This system worked best under one essential condition. The army had to keep moving. Movement was the great luxury of pre-modern sanitation. When a marching army dismantled its camp after several days, it left the most heavily used ground behind. The old trenches were closed, the tents were packed, the animals were gathered, and the entire moving city advanced toward the next prepared site. This reduced repeated exposure to the same contaminated soil. But what happened when the army could not move? During a major siege, an army might remain in the same location for weeks or even months. At Vienna and other large fortresses, soldiers, animals, kitchens, workshops, artillery positions, and supply routes became concentrated around a fixed objective. The temporary city stopped moving. Its biological output did not. Every day created more waste. Every rainstorm increased the danger. The ground around the camp gradually became saturated. Fresh trenches had to be opened farther away or placed closer to other working areas. Clean, unused ground became increasingly difficult to find. If heavy rain continued for several days, drainage channels could overflow. Water moved through disturbed soil. Low areas became muddy. Outer trenches could partially flood. Contaminated runoff could move back toward crowded tent lines. At the same time, thousands of confined animals churned the soil beneath them. Hooves, wagon wheels, manure, urine, and rain transformed firm ground into deep mud. Carts became difficult to move. Animals slipped or became injured. Paths between food, water, tents, and artillery positions became slower and more dangerous. The longer the siege continued, the more difficult the sanitation problem became. Sickness increased. Field infirmaries became crowded. The distance between living areas and waste sites became harder to preserve. Fuel also became a problem. Boiling water required large quantities of wood. Cooking for thousands of people required even more. As nearby supplies were consumed, wood had to be brought from greater distances. A sanitation system could fail not because commanders had forgotten the rules, but because the physical resources required to follow them were disappearing. During these static periods, military discipline became critical. Soldiers could not be allowed to relieve themselves wherever they wished. Unit officers and camp authorities had to direct them toward designated areas. Sanitation was not merely a matter of personal comfort. It was part of military order. A badly managed trench, a contaminated stream, or an overflowing drainage channel could weaken an army more effectively than an enemy attack. The battlefield lay outside the camp, but during a prolonged siege, One of the most dangerous fronts was inside it. Chapter 5. The Invisible Sanitation Engineers. When we look at historical images of Ottoman campaigns, our attention is naturally drawn toward the most dramatic elements: the cavalry, the janissaries, the banners, the armor, and the enormous bronze cannons. But the survival of the army depended on people who rarely appeared at the center of these images. Laborers dug the drainage channels that carried rainwater away from the tents. Water carriers moved clean water from protected collection points toward kitchens, officers, soldiers, and animals. Camp attendants prevented muddy traffic and livestock from entering the cleanest part of the water source. Other workers repaired roads, filled dangerous holes, removed refuse, and maintained access paths between different sections of the camp. Animal handlers also faced an unpleasant but essential responsibility. When a horse, mule, camel, or ox died, its body could not remain beside the tents or water supply. A large carcass attracted scavengers, contaminated the surrounding ground, and created further disease risk. It had to be removed from the active camp and buried or otherwise disposed of at a safer distance. None of these tasks carried the prestige of combat. The men performing them were unlikely to be celebrated in poems or paintings, but their work preserved the operational capacity of the army. An empire did not project power across continents simply because its soldiers were brave. Courage alone could not provide drinking water. It could not drain a flooded camp. It could not remove a dead animal. It could not close a full latrine trench. And it could not prevent flies from moving between waste and food. Large-scale military power depended on administration. Officials recorded supplies. Advance teams inspected campsites. Laborers moved soil. Water carriers protected the flow of clean water. Animal handlers managed the living transport system. Cooks, artisans, servants, and soldiers all participated in a fragile network of daily survival. The Ottoman army did not become a structured military machine by ignoring human biology. It became one by organizing around it. Without the shovels of the trench diggers, the swords of the janissaries would have been useless. The next time you see a grand painting of a historical army marching across Europe or Asia, look beyond the banners and the glory. Think of the moving city. Think of the tents, animals, kitchens, streams, carts, and thousands of human bodies concentrated in one place. Think of the 15 tons of solid human waste produced every day. And think of the far greater burden created by the animals that carried the army forward. The battlefield determined who won the day. But the sanitation of the camp helped determine whether the army remained alive and organized long enough to fight. An army that could manage its water, food, animals, roads, and waste could project power across enormous distances. But every successful solution created another problem. As the roads became narrower and the terrain became steeper, a different logistical nightmare appeared on the horizon. How did this moving city transport enormous bronze siege guns across roads that could barely support an ordinary wooden cart? How many animals were required? How were the wheels prevented from sinking? And what happened when the road simply ended? That is the story of our next film.